Hello everyone. This lab we're going to talking about Y to delta three-phase transformer. So we still have the same transformer bench. Each transformer, the rating is the same, but this time we connect the transformer parallel Y on the primary side and the parallel delta on the secondary side. We also have a three-phase load is 3 15-ohm resistor connecting in delta. So for Y to delta connection, the CSA requirement is also high voltage side leads low voltage side by 30 degrees. The phase displacement is 30 degrees. So we have to follow that standard to make the connection. So here's my connection. H1, H4. H1 on line A, out H4 on neutral on the primary side. Secondary side, X1 on line A, X4 on line B for phase A, then phase B, X1 on line B, X4 on line C, C phase, X1 on line C, and X4 on line A. So here's the connection. Now we look at the calculations. Primary side, Y connection, supply voltage 240 volt, phase voltage gonna be √3 lower than the line voltage. So 240 divided by √3 gave me 138.6. Transformer ratio 2 to 1. Secondary side phase voltage. Primary side phase voltage divided by 2 give me 69.3. Secondary side is delta. Phase voltage equal to line voltage. So for the load, because the load is also connecting delta, the phase voltage equal to the line voltage, 69.3 volts. Phase current, phase voltage divided by resistance, give me 4.62 amps. Line current, √3 higher than the phase current, give me 8 amps. The total kVA for the load, 3 times E phase times I phase, give me 960 VA. So for secondary of the transformer, phase current gonna be 4.62 amps. Delta connection, line current, 8 amps. Primary side, Y connected, I calculate phase current is 2.31 amps because it's a Y connection, so the line current gonna be the same. Now, the secondary is delta connected, so we have to do a delta closure test. Like I mentioned before, for delta, always have to perform delta closure test. If you don't do that, the danger could be a short circuit, everything blow up. But because this is a Y to delta three-phase transformer bank, we do the delta closure test. This time in the lab, we're not going to reading 0 volts. Because for Y delta three-phase transformer, we're going to read a line value when we do the delta closure test. The reason is, this time we're actually reading the third harmonic voltage on here. The third harmonic is, our supply is 60 hertz, but the third harmonic is going to be 3 times 60 hertz, give us 180 hertz. So I'm going to show you on the oscilloscope, you will see something is about 180 hertz in the circuit down there. The harmonic is the thing going to affect the power quality. So the power quality is a very important thing when we generate power. When we're talking about affect the power quality is for when we have the harmonic and the fundamental 60 hertz waveform down there, the fundamental waveform going to change. It's not going to be a perfect sine wave anymore. If we don't have perfect sine wave, and with the third harmonic in the circuit, they're going to cause a bunch of problems in the electrical distribution system. The majority thing going to be overheating for the neutral conductor in the three-phase system. Another thing is they're going to distort the sine wave. They're going to distort the motor torque developed, and also for the computer and other electronic device, they're going to causing trouble. Because they don't have perfect sine wave. But at the same time, those electronic device, the switch, the power supply, they will causing the harmonic distortion in the electrical distribution system. So the power quality is a big issue. We're going to talk about later how we can solve them by using certain kind of harmonic filter or zigzag transformer. But now let's go look at the three-phase transformer bench.